Hi everyone, this is Chauke speaking, facilitator of Building and Structural Construction N5 at Majuba TVET College. Alright, so today I'm gonna be taking you through topic trusses, and this will be our part 1A of our video. Still gonna be using J. Bishop as our reference book. Alright, so let's say we have this problem here. Figure shows below, there's a figure there. Loaded truss which is supported on a hinge at RR and by means of rollers at RL. Alright, and then we are set to calculate their actions at RL and as well at RR. That is the first question, and the second question is to determine the magnitude and the nature of each member within the truss. Alright, so here is the truss. Please take a moment and just copy it, because when we continue we may not be able to come back to this one here. Alright, so here's a truss. It's got 5, 8, 10, 12 and 5. You realize that now this our truss, the pitch is 30 degrees, and if it's 30 degrees at this an angle for these ones which are perpendicular to the member here will be acting at an angle of 60 degrees. Also, if you draw a horizontal line here, you will have 30 and 30 at the bottom, and because this one is perpendicular, which is forming 90 degrees, now the angle in between the force and the horizontal line will be 60 degrees. So this force here 5 and this force here 10, they are acting at an angle of 60 degrees. All right, let's start our problem. Now, what do we have here? What you need to do now, we have to, okay, you can do or you can solve a truss in two ways, analytically and as well as graphically. So this part 1 of the videos, we will be dealing with, or I'll be demonstrating the graphical method. Don't worry, I'm gonna be using CAD. I'm not tutoring CAD, but I'm using this tool just to demonstrate. I find it a little bit easier and also close to being accurate as far as drawing your solving your truss graphically. All right, so what you need to do, we know that the span of our truss is 4 meters. Anyway, when it comes to graphical method, the span is not necessarily very necessary, or it's not that very important. So I'm just gonna say 40. Choose your suitable scale there. I'm gonna say 40, representing 4,000. Okay, and then you realize that I'm gonna be a little bit quick, just for the sake of time. All right, so that is 40, and then this one now will be at an angle of 30 degrees. Let me see. All right, so we've got 30 degrees. We have another one here which is 30 degrees. All right, cool. So this is our truss. This is our truss, and then we also have member here which is going up. We have another member here which is at an angle of 30 degrees and at an angle of 30 degrees. So the most important thing here is that your members must be at accurate angle. So that's the most important thing here. All right, so there is our truss, and then you remember that we have the reaction RL, which is the roller. So now it means that we have just one vertical force there, and we have a hinge this side, which is our RL. So remember that we don't know the angle of our we know that the RL will be acting at an angle. So I'm just gonna put it just like that there, and then very quickly let me just copy this, because I just copied this so that we save time. Let me just copy this now. Let me just copy this. Let me just copy this. And then, okay, so here we have R, RL, and then here we've got RR. Okay, right. All right, let me just reduce this text here to be 1.5. 1.5. That's it. Let me just, okay, right. So you will also remember that the first force here is 8. So take note of this. So what we're going to do now, you are going to have another scale, which is a force scale. The forces here must be scaled. For example, you've got 8 kilonewtons and 5 kilonewtons. I remember I said copy the problem so that you see what we're gonna be doing. I may not go back to our slide. Okay, let me just show you here. All right, so we've got 5, 8, 10, 12, and 5. So now you must draw 5 kilonewtons at the appropriate angle, which is 6 degrees, and also at a scale. All right, so you can choose a stable scale, and then this one as well at a scale, using a scale, 10 using a scale, 12 using a scale. All right, now let's see. I'm gonna say the first one here is 8. I'm gonna use 8 as it is. That is 8 as it is. You may be using 1:2, which is fine, or you may use 1:2 is fine, but I'm gonna use 8. Okay, I'm gonna use 8. All right, and then here, this one now should be at an angle of 60 degrees, which is 5. I'm gonna use 5. Okay, let me come here. This one will be 12. I'm gonna say 12. Enter. I'm gonna say so I don't know whether it's too big or not. I do have enough space. I do have enough space myself here. And the other one at an angle of 60 is 10. All right, so I'm gonna hit 10 there. Okay, now that we have that one, okay, we're left with this one here. 5 as well. 5 as well. All right, we hit enter, and then we'll say now what we're going to do now. Remember, this one is 5, this one is 8, this one is 10, this one is 12, this one is 5. I'm not going to label them just to save time. you should have for sure you do have the forces by now. What you need to do now, it is to complete a parallelogram. All right, so I'm gonna offset this one. I'm gonna offset this one. I'm gonna offset it to here, and I'm also going to offset this one using you can use your set squares. Okay, I'm gonna come here, and then I'm gonna get my resultant. My resultant is this diagonal line here from here to there. All right, that's my resultant. And then I'm gonna do the same thing here. Remember, I've got two forces. The other one is inclined, the other one is straight. I need what? The resultant of the two forces. So I'm gonna offset this one here. There we go. I'm gonna offset this one as well. Remember, you're using what? You're using your set squares. All right. You're using your set squares. Okay, let me get it correct. I just need this one here. Okay, great. And then I'm gonna draw my line or resultant from here to there. I need the correct point. Okay, just leave it there. All right, now I have that one. I don't know about this one because this one is the only vertical force that I have, or is the only force that I have. So I don't need a resultant. Even if this one was inclined, because it's the only one at this point, I will not need a result. It's a resultant on its own. So if two forces are acting at the same point, the other one is inclined, the other one is maybe vertical. Now I must get the resultant of the two forces, like I did here. Okay, remember this one is 5 kilonewtons. Also, this one I decided to draw it according to the scale. All right, now that I have this one, now I am going to, let me just label this one very quickly. I'll copy here. Let me just put it here. Okay. Let me just move it here. Let me switch it off this one. Okay. So remember, this one was A, right? This one was A. Okay. Let me copy this ones here. Copy this ones here. Very quickly. Okay, so this one was A, and we had B here, and then we no longer have B, so this one would be what? Would be C. Remember that, and then D, and then this one will be F. It will be E, sorry, and then this one will be F. This one is our F, and this one will be our G, and then this one will be our H. Let's skip I and use J, and let's use K here. Let's use L. Okay, L. Labeled, right? Remember, we got rid of our, because our B was between these two forces. Our D was also between these two forces. So now we got rid of those two. Now we've got our resultant. Now that you have done that, you come here. You come here and offset this one. All right. I'm gonna make my resultant maybe okay, let me not interfere with these ones. I'm gonna take this one. I'm gonna offset it now. Now I need my polar. I'm gonna offset it. Remember, using your set square. All right, using your set squares. I'm gonna offset this one to the other side. All right. Say here. Okay. I'm gonna offset this one here. So that is AB, right? Okay, let me just label this one here first. Okay, let's say A. I'm gonna copy this one here. So that's your force AC. Sorry, this will be your force AC, which is your resultant. Okay, A. Let's copy this one here, and this is your C. This is your C. All right. Now I'm gonna go to CE. Now I'm gonna copy this one. Now you are offsetting this using your what? You are offsetting this using your. You are offsetting this using your set squares. Okay. I did it wrong here. Let me just. Okay. There we go. So we're gonna copy this one here. So that will be your E. Okay. Now we want EF, which is vertical, and then we'll offset using your set squares. I'm gonna come here, and I'm gonna offset it here. Great. Now that I'm done with that one, I'm gonna locate my 0 anywhere along this line. And okay, I'm just gonna put it there. Let me put it here. Okay, so that would be my point 0. Just a small circle there. All right, so now that I've done that, I'm gonna join. This is my point O, right? I'm gonna join AO very quickly. AO, OCO. All right, I'm gonna join EO, and I'm also gonna join EF. Okay, this is my F. Yes, sorry. Let me just copy this one. Here, there is my F. Right, there is my F here. Okay, what did I do now? Okay, so here, that's where you get your F. EF, the 5 kilonewtons. All right, I'm gonna change this one to color. Let's use this one, right? Okay, so this one, my AO, CO, EO, FO. Okay, now that I have these ones now, what I should do, I have to extend my line. I have to extend my lines. All right, let me change these ones to yellow. I'm gonna change these ones to yellow here. Another color so that they are distinguishable. And then, well, let's use green. Let's use green. and then these are the same ones that I put here, or offsetted here. Let's just go in there. All right. Right. So now what I need to do, I'm just gonna extend this one just a little bit down. I'm just gonna extend it vertically, extend it downwards, and I'm gonna extend this one. I just gonna draw a vertical line going down here, all right, where my reactions are. Okay, so now what I'm gonna do, I'm also going to extend my external forces. I'm gonna extend it vertically down. All right. Okay, because these ones are at an angle, what I'm gonna do, I'm just going to, okay, let me see. I'm gonna extend this one. Remember, with your extend it. Okay, I'm gonna extend this one as well. Don't lose the angle, don't lose the angle. All right. Okay, now let me try again. Okay, there we go. All right, so I have this forces extended. Okay, faint lines there. All right, now that I have those ones, what I'm gonna do, I'm gonna take this back to my space diagram. Okay, this is more like when we are doing our beam in N1. So I'm gonna start with this one. Remember, this AO is gonna be under this H section, between the reaction and this one, and then CO is gonna be under this C here, and then EO is gonna be under this E here, and then FO it's gonna be under this portion here, F. All right, so I'm just gonna copy this one here. Remember, you're using your set squares. What you do, put your first set square on the line that you want to offset, and then at the bottom you put the second set square as a controlling set square. Okay, and then you slide your set square, you come here, let's just put it here, right? Okay, and then we're gonna copy this one, we're gonna offset this one here, so where they meet, that's your C. All right, then let me cut this one here. We don't need this one, we don't need that one. Okay, and then we're gonna offset E as well. We are offsetting it, offsetting E to here. All right, and then we are also offsetting F. Let's copy F, OF, yeah, somewhere here. All right, now that I have that one, what you need to do, it is to get this line. I'm gonna join this line here, which is here. I'm gonna join this line at the beginning of this one here, right at the beginning, and I'll go towards the other end, was crossing that reaction line. All right, now that I have that one, let me change this one to a color, distinguishable color. let's use this one, right? All right, so now I have to take this one back to, so this one will be my GO. Okay, yes, so let's take this one back to 0.0. So using your set squares, I'm going to offset, put my first set square here, and then have a controlling set square, and then I slide it back to 0.0. All right, I'm gonna go to O. Now that I'm here, remember RL, that's where I have my roller, which means it's the vertical force going up, right? So now what I'm going to do, I know I'm gonna come here. Remember, where there is RL, RL is closer to A. Okay, RL is closer to A where there's a roller support. Okay, so I'm gonna come here to A. I'm gonna draw a vertical line, just a vertical line going down. Vertical line. Let's put this one here. Yeah, at 90 degrees, right? Vertical line going down. Let's trim this one. All right, right this line, right? And then I'm gonna draw another line from here. This one is the reaction RR. Reaction RR is the line from here to F. Remember, RR is close to F. RR is close to F. So it's from here to there. All right. Now this point where they meet here, it will be your point G, right? It will be G. All right. So therefore, these are your reactions. All right. So reaction is the distance. Reaction RL will be distance from A to G, and then reaction RR will be distance from F to G. All right. So let's find out what that reaction is. Copy. Let's put it here. All right. Let's put it here. Okay. We'll say RL is equals to AG, right? Which is equals to, and then RR is equals to FG, which is equals to, okay, let's come here and measure this. Let's start with AG. When I come here, I want to measure from here to there. I'm getting 18.63. all right, 18.63. So my force is 18. Remember, I use scale 1:1. Okay, 18.63. You may not need scale 1:1 for you may not be suitable. All right, maybe for the forces you can use 1:2 there, or anything that is suitable. 0.63 kilonewtons, right? And then we will come and measure this one now here. It's a FG. If I measure FG here, what do I get? I'm getting 20.76. all right, 20.76. okay, let's come here. 20.76 kilonewtons. But I'm also interested at an angle. Can you see that this one is inclined? So I want to know what is the angle here. So I'll come here and create a horizontal line. Okay, horizontal line, and then you will measure now the angle. Let's see what is the angle here. The angle between this one horizontal and that one. It's giving me 69 degrees, right? It's giving me 69 degrees. So at 69 degrees, let's see. Okay, because it's going up, it's gonna be north of towards the left of west. These are our reactions. Reaction RL is this one. Reaction RR is this one. You must also remember that graphical method, it is not the most accurate, but if it's done correctly, the error or the difference will be too small. You see. So this will be our reactions. All right. Let's stop our video here. That would be our part 1A. Let's do part 1B, where we'll be determining the forces within the members. All right.